since the previous year, we were mainly involved in the different flight planning applications. So we learned very well what data acquisition looks like, and we have a lot of clients. So but last year we introduced also a data analysis platform, because we decided that we need to move towards the kind of a one-stop shop for those who professionally work with drones, with remote sensing, data processing. And actually, we also identified several pains from our client, which in our opinion, not entirely resolved. And of course, as you might know, nothing nothing is static. So the industry, and especially construction industry, moves very fast towards the purely digital industry, and remote sensing with drones, with satellites, brings a lot of additional knowledge to all participants. And of course, the tools that you use for that are very important. They make you efficient, and they allow you to properly work with huge amount of data that you may see when you participate in such projects. So actually, as one popular author said, the future is already here. We just need to understand that it's here. That if you do not understand that, you can use some modern cutting-edge technologies, then you just may lose the battle with your competitors. Okay, how we see the main construction site monitoring task right now. So first of all, as I already mentioned, you have to work with a huge amount of data that you acquire either from drones or from satellites. But we also figured out that satellites are not very popular. But anyway, with drones, this high resolution, highly detailed data, either just raw images or already processed orthomosaics and elevations. So storing this data is the first and very important step, and making a proper structure and giving access to this data to your teammates, clients, subcontractors, whatever, partners. So not an easy thing, actually. Then, of course, when you gather this data and you make an archive, and you have some data for surveys taken in different dates. So you have some kind of a timeline. Of course, you need to make kind of a progress tracking, and also you need to compare the actual data, the orthomosaics, 2D data, 3D data, with your project plan. Maybe not yours, but your client, your customer. So in most cases, you compare this actual site state with some technical drawing from CAD system or BIM system. So that is the second thing. Then, if you archive and you store this data, then it's very often that you need to understand what has changed. Maybe not on the entire site, but for a particular area of interest. And that's not only about just side-by-side comparison. In most cases, we see that our clients want to see the progress for many days. So like for several months, or maybe for several years, because understanding what happened and when with the construction site sometimes is very important, especially when you make, I don't know, when you make some deconfliction with property owners, which had some property on the territory of construction site. So easy access to this historical data is very important. And of course, it is very important to compare data for, say, just this week and previous week. Yeah. Then, of course, as we all see, and that's what you confirm just by voting, measuring volumes, and building reports, delivering you information about the status of earthworks. It's very important, that's for sure. And in many cases, you need to see what is the true digital terrain model. So when you make aerial photography, in many cases, you have some structures, man-made structures on the surface, or you have vegetation. So cleaning the DSM and generating DTM is important thing. And of course, then we just come to the most interesting thing, in my opinion, is detecting various things on orthomosaics, counting and measuring, counting detected objects in a certain area and measuring occupied area sizes and making some reporting. That's the first. And the second is just making a vectorized representation of captured orthomosaics, so generating the plan. Because the on next stages, in most cases, you need to collaborate somehow with your or your customer's project, which they manage in such tools like Autodesk Civil 3D or GIS system like S3, ArcGIS, etc. Or even in QGIS. That depends on the project. So, yeah. So as we now which data can we use in Atlas? Of course, we work primarily with drone data, just because many of these tasks that I just mentioned above, they require a good level of detail, just to make a proper measurement or distinguish a certain object on the Earth surface. So you need a proper detailization. That's why drones are so popular, and that's pretty obvious. That's not a secret. But we also work with satellite data, and because by its nature, so satellite data can be represented by the same GOT files. So for our system, there is no difference, and you can use it as well. And by the way, shortly we will have a separate webinar explaining how to use satellite data in Atlas. So, but like first things first. So let's see how it looks like in Atlas. So maybe I did it too fast. So uploading and sharing data. So that's the first topic. So you need to make a storage, properly organized storage. And Atlas, as you can see, is a web-based application. And you can structure your data into projects, and then you can have a data sets layer. And now I want to just pause for a moment and tell about the meaning of data set, because it might be a little bit confusing. So what is data set? What is the meaning of the data set? So that depends. We do not enforce any policy, specific policy here, because depending on your work nature, the semantics of this structure can be very different. So for example, if you do regular flights over the same construction site, then it makes a total sense to make to dedicate a project for this construction site and put data from each individual survey into data set, because data set can be linked to a date, and then within one project. You can see your data on a timeline, make different comparison things, and etc. If you fly like for just one client, and this one client has many assets, but you know that you will fly just once to just deliver a result, and that's it. Then in this case, you can have a project for one client, and then for each asset, you will have a data set. So that's up to you. It's up to you. So we are going to increase the flexibility of the structure later, introducing additional tagging mechanisms that will allow you to search, to improve searching capabilities. But even now, it's very flexible and reflects almost everyone's needs. So then, when you create a data set, you can actually upload data. So you can upload either raw imagery and stitch in Atlas these images, or you can upload orthomosaics. And here's how it looks like. So again, you can see, inspect your orthomosaics. You can see the area size, and also you can upload additional things like an elevation, and then see how this elevation combines with the orthomosaics, change the transparency layer, transparency level, and also seems like I restarted it. So, yeah, change the transparency level and generate the thermal map out of your, with different color coding for your elevation data. So again, a short summary. As a data sources, we can use data from drones, like just raw images. Also, you can use data from satellites. As for formats, you can use JPG. Also, actually, you can use PNG files and GeoTIFFs. The types of images are raw images, orthomosaics, elevations. Later, I will show separately about the vector data, but now I'm speaking about the data that you get out of your regular survey, either with drones or with helicopter or the satellite. So, and key facts about this, our data storage system is that it's optimized for terabytes of data, literally. So, and also we have a user management system that allows you to specify which part of the team accesses which project with which level of privileges. And yeah, as I already mentioned, it's a web-based application, so it works in any modern browser. Okay, then next important thing, comparing current state of the site with the project plan. So, but first let's walk through the key activities that you might do and like key reports which you might need to build either for your organization if you work in, like if you are in a construction organization, or for your client if you work as a service provider. So of course, earthworks, and so this is where you need to control. You need to compare the planned data with the current state. Like sometimes you need to compare boundaries of the objects, that the excavation works, they happen in the proper place. Also, you might need to control the placement and the location of the temporary and permanent structures. So this is where it's very useful to combine the vector data and the orthomosaics. Also, you might check how certain works happen, like vegetation removal or where different water resources located, material placement, is it in the proper place, or material just placed on the road where your heavy trucks have to go. Also important thing is the waste management, because what we see right now is the different penalties from environmental monitoring authorities. They can be significant and they can affect significantly the construction process and many other things. So how it looks like in Atlas. So the first, in most cases, you have some technical drawing in a CAD system, like Autodesk Civil 3D, for example. So you can export this data as a DXF and then upload this file to Atlas. But what is important here is that in many cases, this technical drawing, it is not georeferenced. So you need to somehow specify the these matching points between the technical drawing and orthomosaics. And we have a mechanism that allow you to specify ground control points on the technical drawing that will help you to properly georeference the local coordinates of the technical drawing with the orthomosaics. This is how it looks like. So it's a pretty simple process. You can either enter the coordinates manually if you have a list, and in most cases, I know people have a list, but you also can just, if you don't have such a list, and you need just some quick and rough georeferencing just to see how it combines, you can make it visually with a map. Yeah, and then you just run a georeferencing and open this vector data in your data set. So this is how it looks like. We have a separate layer stub where all vector data uploaded to the project is available. So you can compare. This red line is like a road contours. We see that not very accurate, but yeah, this is how you can easily compare the orthomosaics with technical drawings. Then volume report, cut and fill. So we have a basic functionality which allows you to analyze elevation data and give you a quick estimate what is the volume of material or placed in a certain working area. And to make this calculation, what you need to do, you just need to specify, first of all, you need to enable the elevation. So then you can specify the area of interest, the working area for which you need to calculate the volume. So, and our software makes an interpolation of the volume using the heights on the boundaries and calculating the heights inside this area. And this algorithm can work not only on the straight surface, but also on slopes, because we take altitudes from the boundary. So if the altitudes on the boundary of the area is different, so we will use these values for interpolation. So it should work in slopes. And yes, then after this volume calculation, you can export results to PDF and share this information with others. So then, making a digital terrain model. Again, so how it works. Because we have a digital elevation model in our system, so you can easily cut certain areas with, for example, vegetation and interpolate altitudes around this, not around, but within these areas. So it looks very similar to the previous demonstration with volume calculation. What you need to do is, so you need an elevation, then you can specify the area which you want to interpolate. Yeah. So then you select the name of your neurally generated elevation model. So we do not overwrite your existing elevation model. We just generate additional layer for you, so you can always just compare original elevation model with newly generated. And then after interpolation, you see this newly generated model, and this is how it looked like before. Now this is how it looks like after interpolation, and yeah, that is again, that's original. So you see the difference, that the interpolation was successful. Then you can export this interpolated GeoTIFF and use it in your other applications. Now that's the most complex topic. Generating the vector data out of your orthomosaics. And this is where our AI engine comes to the scene. But first, before I will demonstrate you how it looks like in our application, I want to discuss with you some fundamental things which, as we see, significantly, the understanding of these things significantly affect your performance in the Atlas. We actually, one of the key idea of Atlas is delivering the power of AI to people who are not familiar with AI. So we do not expect that those who will use Atlas will be a data scientist. So we support also a complex API for them, but we see that the main category of users is just a normal human with some professional skills not related to AI. So that is why we try to make this process as simple as possible, but some basic knowledge of key concepts, that is what you should know. And I will try to explain this concept like in 5 minutes. So how AI works, and basically you show you what you want to detect, and AI tries to find similar objects based on provided examples. That's the basic concept. And that brings us to a very important thing to know, is that the quality of the AI model, AI detector that you build in Atlas heavily depends on the quality of annotation. How the typical process looks like? It consists of 4 steps. So first of all, you need to annotate manually several data samples. Then you just press train button in Atlas, specify the name of your detector, and Atlas do all the magic under the hood and demonstrates you some results. Then you need to, when you see these results, you can validate. And if you are not satisfied with results, you can just fix, for example, some mistakes in annotation and train this detector one more time, or just extend your data set a little bit to make your detector a bit more generalized than it was before on the previous step. Then, when you are satisfied with the detector, you can run train detector on the entire data set. But when you're practicing, you can run your detector only on a small working areas, which is very fast. And literally, for many data sets, you can, in a few hours, you can get some significant results. Another important thing that I want to tell you is how GSD affects this process. And here on the slide, you see pictures of cars taken with different GSD. So on the left, you see the picture from the satellite. And as you can see, you almost cannot identify the car on the road. So you see that, okay, something red, or maybe something gray and white, but is it a car or is it like a garbage container? Hard to understand. Then in the middle, you see the picture taken with 15 centimeters per pixel. And yeah, for satellite imagery, it's 50 centimeters per pixel, which is quite cool for satellite imagery. In many cases, the data has a lower resolution. So then the picture in the middle with GSD 15 centimeters per pixel. And that's like an average survey for making a topographical plan. So here you already can see the car. So you can see the shape and even of the road. You can see the road marking. So so on this picture, you already can identify certain objects. But for example, on this picture, still very hard to identify manhole on the road, for example. It's too small, you know, its physical size is, I don't know, less than 1 meter, maybe 80 centimeters. So if you have a GSD of 15 centimeters, then you have like a 5 by 5 pixels. And that's important to understand that to detect objects of a certain type and of a certain size, you need to have a proper GSD. That's a crucial thing. And the rightmost picture with GSD 3 centimeters per pixel, it's very detailed, so you can see even the you know, the boundaries or the connections between concrete segments of concrete road. It's very detailed, so you can see a lot of things here. So properly prepare manual annotation. That's a key to success, because depending on the quality of the annotation, you may save a lot of time training your detector. And here are several important concepts about the atlas. So one detector in our concept now, at least. Maybe we will change it somehow in the future. But now one detector should work with objects of one type, meaning that you train detector for cars or like for solar panels. So we do not recommend to have objects of different types annotated for one detector. Yeah. Then it is very important to properly separate objects of interest from background, because neural network, it's like a kid, newly born kid. It knows nothing in most cases. Of course, we use some pre-trained models, but in many cases, generally speaking, it knows nothing about the world around you. That's why you need to guide it. You need to specify what is object of interest for you and what is the background for a proper separation. Then you need to annotate enough data. Typically, we recommend, depending on the data set size and the complexity of the object, we recommend to annotate from 2 to 10% from the entire data set. And the bigger data set size, the lower percentage. Because if objects have a good level of generalization, then the absolute amount of annotated data for the big data set, of course, will be sufficient. So, and what we see that with proper annotation, you can get a very accurate results, more than 90% of accuracy. Of course, you can get lower, but again, proper annotation is a key to success, and this is how you can improve these, the confidence of detections. Now, I prepared several samples to explicitly demonstrate what is good and bad annotation. at least in our terms. But actually, it works for most of machine learning, tasks. So here on the picture, as you can see, for example, we want to detect scratches on the road. And as you can see, we annotated only a very small segment on the road. This red solid line, it specifies the boundaries of the object of interest. And a red dashed line, it specifies the boundaries of the background. So as you can see, within the background, there are a lot of not annotated scratches. And what that means? This means that neural network will treat these scratches as a background, but that's not what we expect. We want we want all scratches to be detected properly. So we have two solutions here. We can either reduce the size of the background, so it will cover properly annotated objects, and the remaining space will truly belong to background. Or you can just add more object annotations in here and annotate all not annotated scratches. So another example, why this annotation is bad. Because you annotated objects, but you have not specified, actually not you, but me. I have prepared these examples. So why is it bad? Because I have not added a background. So the solid line, I remind you, the solid line is an object annotation, and the dashed line is a background. No background here, so neural network. So it will try to identify how the background may look like here, but in most cases it will just not work. So our solid recommendation, specify what is a background. Here, again, not good. Why? Because as you can see, we have a background, we have object annotation, but object annotation covers big areas of relatively good asphalt. So if you need a more accurate contours of cracks on the asphalt, you definitely need to specify polygons more accurately. So this will still work if you need just a rough estimate of the quality of your asphalt surface. In some cases, that's good, but you need to understand why, for example, in some cases, the detection result covers too much space and do not generate accurate contours. Maybe because you added too much amount of background to the object annotation. And this last example is good. So here we see that all scratch is properly annotated and background is also very well defined. So that's, again, data annotation is a very important step. So it is better to annotate less, but with a good quality, rather than having a huge amount of annotations, but with a poor quality. Just remember this. So now I will show you quickly. Seems like we are very squeezed in time because we have some questions also. But I will show you how it looks like. So, and here, this white dashed line is a working area where we will run our detections. So here, we run, first of all, we run our building footprint detection. It was pre-trained earlier, and now we just run it on this working area. And in some cases, the detections generate either not very accurate results or too many vertices on the polygons. We have tools which allows you to simplify the shapes and remove unnecessary vertices and remove also results with a low confidence. Now we are showing how you can annotate, for example, solar panels. And I want to put it on pause right now. Yeah. So as you can see, here the annotation looks very fast because the user just clicks the solar panel and it is automatically highlighted. And that's one of our cool tools. We call it the magic wand because it uses not like some heavy neural network, but different machine vision techniques which help you to annotate objects just with 1 or 2 clicks, find their boundaries. And that can save a lot of time. And sometimes you can even just use this tool without running any neural network to get the vector layer. Because many objects, like for example, solar panels, they have a quite uniform color. So, and the texture of this object is very uniform. So this tool will work very well. Of course, this tool will not work good, for example, on a tree, because tree, as you can see, has many shades of green color, and that's why in most cases this tool just not perform well. But for asphalt, for concrete surfaces, for solar panels, for roofs, water surfaces, a lot of examples where this tool is very effective, and you will see. Just notice that when we will show next examples. So we annotate data and we assign here the object type. Here it's just a PV panel. So we do annotation, specify objects of interest. Then we specify background, and this is a background. We add a bit more of annotations, make a background, yeah, and then just press train, specify the object type for which we make a training, and specify the detector name. And basically that's it. The training runs, and when it's over, you see the results. So it's pretty accurate. So a lot of solar panels detected properly, and you can do the same thing, for example, for pools. Again, here we annotate with our magic wand tool, but of course, if magic wand doesn't perform well, you can use just normal circles, polygons, rectangles to annotate data. In some cases, it might work faster, but as you can see, magic wand is pretty efficient. So again, and the process is absolutely the same. So we do some manual annotation first, then we specify background areas and train the detector and inspect the results. As you can see, for each object type, you can specify individual color that will help you to distinguish between different objects when you have a lot of objects on the map. But you also, of course, you can control the visibility of layers. So it is very similar to what you have in a normal GIS systems. Yeah, and this is where magic wand can be very efficient. So you see how fast you can annotate, for example, asphalt surface. So it can give you the road contours very fast. Of course, it will require some additional polishing. So you can just polish corners. Also, you can remove points from the polylines. But if you need a really fast annotation, you can benefit from these tools very much. And also, these annotations you can export to either GeoJSON or DXF, other vector formats. So both manual annotations and automatic detections, you can use them in Atlas for example, for measuring area sizes or calculating number of objects in a certain working area, or you can export this data. And now I think we are on a part where we show how we can export to DXF. We configure the visible layers, then we specify the target coordinate reference system and export selected layers to DXF. Then we can open these layers in your just a conventional CAD system or GIS system. So this is how it looks like. So then, what are possible deployment types? Actually, I call it deployment types. Maybe it's not a clear term. So actually, we have two forms how you can access Atlas. The first is we offer Atlas as a cloud-based service. So you can visit our atlas.ugcs.com, register, get your 14-day free trial, or subscribe to some bigger plan. Use our cloud-based storage. Use it from any place, like a normal cloud-based service. But other option, we understand very well that many companies, many construction companies, mining companies, huge businesses, even medium and small businesses, they're very they're very aware about the data privacy and commercial secrets. So we have another option when Atlas can be deployed either to your private Amazon AWS account or Microsoft Azure, or even to physical data center. So the Atlas can be deployed fully on premises, even without access to the internet. And it will be available only in your private network, in your organization, and you will use it for automating the work of your drone team, data acquisition team, whatever. So that's the second option. And also, in case of cloud, we very open for discussing. If you are not satisfied with our plans, we're very open to providing different options, different combination of processing capacity and say cloud storage. So let us know. We're very flexible here. A few more words about Atlas on premises. So in case of Atlas Cloud, we sell the subscription, and because we provide our own computational resources and storage, we have different plans with different capacity in terms of storage and computational resources. Because actually we need to cover our own expenses for these computational resources. And that is why we limit storage and processing capacity for different plans. So in case of Atlas on premises, we have a different model. So we offer a license per server. And as I mentioned before, all data is privately stored on your server. It can be cloud-based instance or a physical server. And if you think about starting with Atlas, the requirements, for example, for a physical server, they're not huge. So to start with Atlas, you need, in most cases, for say a team, 5-10 people, and several like terabytes of data per year. In our opinion, you can start with just 2 high-performance computer, not even special servers, but workstations powered by Linux operating systems. Of course, we recommend the high-performance configurations with like Core i7 or i9 and a good amount of RAM, and of course, at least an SSD drives for a faster operations. And one machine, at least one machine, has to be equipped with a good video card, like NVIDIA RTX 2080 or modern day NVIDIA released a few months ago, a new generation of cards. So you need a GPU because all these photogrammetry and AI processing things, they require GPU for better performance. And you need a storage. It can be either just a hard drive in one of your computers with sufficient capacity for your needs, or it can be a network storage. So not requirements are very moderate for such a thing. But when Atlas runs on your own computer, we do not limit you for amount of AI processing capacity, because like that's your computational resources. So we charge you only for the license per server, and you can run multiple computational. So you can run several instances. You can have, for example, several GPU instances which will run AI tasks in parallel or photogrammetry tasks in parallel. And another important thing about on-premises solution is that we offer our own photogrammetry processing engine, and it is based on UGCS mapper. But the architecture of Atlas is flexible, so it is easy to connect such different photogrammetry processors. So if you already standardized for your organization such things like Metashape or Pix4D or Correlator 3D, and these engines provide you with some command line interface for running batch tasks, then these engines can be integrated into Atlas easily. We already know that, and that's possible. And so you will use the Atlas as a storage, as a web-based interface for working with your team, but under the hood, you will still use your favorite photogrammetry processing engine. So we almost done, and I wanted to share with you just several facts from the previous year. So it was quite successful for Atlas. So we processed like several hundreds of gigapixels of data in our cloud and several terabytes of data, and more than 200 new organizations joined joined Atlas project. So yeah, it was good, and we and actually we look very optimistically to this year, and we think that the tools for digital constructions, they are evolving very fast, and we also want to be part of this process because we think that we can contribute significantly. Thank you very much. Now I'm ready to answer some questions. So we almost out of time.
Yes, we have some questions. So one of the questions were, do we support this and that type of drone? So just to clarify that for Atlas, it's no matter from which drone the data is coming. So
that's correct.
And for UGCS, yes, we have the supported drone list published on ugcs.com. So yeah, okay.
So we have another question: can we use Atlas in a system out of internet? So Atlas on premises can be used without internet. Then can we specify many areas with vegetation and interpolate all? Yes, you can. Is Atlas hosted on Amazon, Azure? Now we're using Amazon. Yeah, that's not a secret. Like, that's one of the most popular services in the world. Can the AI detect plant type like mango tree, leaves in an environment like the Pictera? Yes. Actually, the general answer is yes. Again, just pay attention to the GSD. So yeah, it should be sufficient to distinguish like mango tree from the background and maybe from other similar objects. So that's important. Do you plan on expanding the server capability with only 12 cores? I can see large projects taking extended processing. Actually, we do not limit you in the number of cores right now. So we can utilize as many cores as you have. So there's no hard limitation for that. So actually, if you like that, if that does answer your question, just let us know. Just drop us a message. We can discuss this high performance issue in more detail. But in general, you can run several computers, and you can vertically scale each computer as much as you need, improving the increasing the CPU performance, etc. Is it suitable for creating crop classification trained data as well? If I got your question right, then I think my answer is yes. So you can train multiple detectors, which will give you, which will identify areas occupied with a certain type of crop. So if that, again, if that's not the answer for your question, just please clarify it. You can drop us a message. We're always happy to answer. Does it support iPad, iPhone operating system? Again, Atlas is a web-based application, so the user interface is just like an ordinary website. So you can open it on iPad and iPhone. But for smaller screens, we reduce the number of available features. So, for example, complex editing is not available on iPhone because it's impossible to do that just with your fingers on this very small screen. So, but you can for example do some scouting work when you detected something, and this detection results available on the map, so you can go to the field. And our website supports GPS services, so you can see your location on your iPhone on this map with detection results. So you can, for example, move to a detection result and inspect it in offline mode. So that's what you can do. What about support for reality capture? Again, the Atlas has a very scalable architecture. So the requirement here is very simple. So any photogrammetry engine which supports some command line interface or API can be integrated with Atlas, like any other software. But we, from the very beginning, we designed Atlas in such manner that you can substitute a certain model. So again, in on-premises, if you don't like our out-of-the-box machine learning engine, not a problem. You can implement your own and connect it to Atlas. That's possible. Are there any integrations with ArcGIS platform? We're specifically interested in how to leverage the Atlas AI ML output in ArcGIS Online. So now all the outputs of Atlas are in a very standardized form. So as I mentioned before, so it's like a GeoJSON or DXF or other vector formats. So you can upload to ArcGIS Online. If you want to push directly with a single button from Atlas to ArcGIS Online, there is no such a feature right now. But again, let's let's discuss separately. We have a lot of things on our roadmap, like different simplifications and different integrations, possible integrations with other systems. So I'll be very happy to talk to you separately, and I understand that that's not hard to do. I just need to understand how important this is for you and like what benefits can it bring to your project. So just just drop a message, please, and I'll be glad to talk to you. So what type of volumetric measurement do you have or plan? So right now we're doing simple volume calculations for the specified area. So we specify the polygonal area and we show you cut and fill volumes. And on the roadmap for Q1, Q2, we have several additional things like comparison with planned 3D surface, and also cross-sectional diagrams. So yeah, again, just post us a message if you need something specific urgently. We will see how we can deliver it faster. Would it be possible to send me your presentation? I would show it to my colleagues. Yeah, please drop us a message, or we will revisit all the questions and answers after the webinar. So yeah, we can share. Yeah.
Yes, we have pretty much a question. So the recording will be published on atlas.ugcs.com. So you can, in the presentation, the videos will not, so it will be hard to send you all the presentation with all the videos, but the video recording will have this all information, so you can replay the videos and the presentation. So.
Actually, if you need just a PowerPoint file, so you can also drop us a message. If you need it for demonstrating to your colleagues, not a big deal, to be honest. Sorry if it has been asked already. Are you taking steps to market to the US government? DJI drones are on a ban list. In terms of Atlas, we are not locked to any drone vendor. So we support images of different formats. So you can fly with any type of drone, or you can take satellite imagery and upload to Atlas. In terms of, if your question relates to our flight planning software, then we already support other options like autopilot-based drones, Pixel-based drones. So recently, if you might know, we added support to Parrot and Afi. It was last autumn. So we have different options. So please, if you have any specific questions or you are preparing for some tender, for example, just don't hesitate to send us a message. We can answer it in more details, but technically speaking, we are not locked on DJI absolutely. Is it possible with a thermal camera identify different areas and calculate them using AI and Atlas? Yeah, so if you work with RGB, JPG, yes. If you use GeoTIFF files, then not yet, but we are going to add it. Do we have access to yours or others' deep learning data sets? Actually, we are we are not using our clients' data sets for training any detectors. So our clients train detectors on their data for their own purposes. So we value the privacy of our clients. So of course, we pre-train detectors on the data set which is either public or was explicitly allowed us to use for these purposes, but we do not like share data sets or somehow use data sets of our clients. That's not a good thing in our opinion. So what about cross sections? That is on our plan. We're going to release it at the end of Q1 or Q2. We are designing this function right now. So if you have any suggestions how you want this feature to look like, then feel free to message us. We'll be glad to discuss with you. How does Atlas cooperate with other AI solutions? Is it just a simple API? So we have our own AI engine, which technically we can provide access to API. Now we do not use any third-party AI solutions, but as I mentioned before, so for example, if you want, and especially that works well for on-premises, if you want to build your own AI part, but you still want leverage data storage capabilities of Atlas, project structure, annotation tools, so you can build your own module according to our specification, which can be easily integrated with the core Atlas infrastructure. Again, let us know if you need more information on that, or if you have some specific project. Can we, the last question, sorry, Sabine, about the industrial inspections, that's quite interesting. So can we use it for industrial inspection tasks with automatic annotation and reporting? Yes. So if, for example, you do not deal with orthomosaics, but work just with separate images, you can do object detection on just separate images and then filter these images and see on which images you have a certain type of detected object. So yeah, that's possible.